District Common Assessment DCA Review. On this first one, we're going to prove, given A is parallel with B and B is parallel with C, we're going to prove that angle 3 equals angle 11. The first statement in any proof is always given. Then it tells us that angle 3, which is here, is equal to angle 6. So here's 3 and here's 6. In the perspective of A and B, both 3 and 6 are between A and B, so they're interior angles. And they're on opposite sides of the transversal, so they're alternate interior angles. And since we already knew beforehand that A is parallel with B, then it is okay to say that 3 is equal to B because they're congruent. So the reason would be the alternate interior angles theorem. That is one of the theorems that's on the list of theorems and properties that I gave you a couple weeks back on pink paper. So that property says that if two lines are parallel, then their alternate interior angles are congruent. All right, statement 3, B parallel with C. The reason for that one is it's also given information. And then statement 4 says that 6 is equal to 11. So here's 6 again, and here's 11 now. In the perspective of B and C, both 6 and 11 are exterior angles, and they're on opposite sides of the transversal, so they're alternate exterior. So because they're alternate exterior, they're going to be equal or congruent. So the alternate exterior angles theorem is what is our reason. Now for the last statement, it's a little easier to see if we pull some important information off to the side. Back in statement 2, we said that angle 3 was equal to angle 6. And then in statement 4, we said that angle 6 is equal to angle 11. Now in statement 5, we're saying that angle 3 is equal to angle 11. Well, because both 3 and 11 are equal to 6, then based off of the transitive property, we can say that 3 is equal to 11. So we cut out the middleman, and because we're using the transitive property of equality. So that's our reason for the last statement. Again, we were told that 3 was equal to 6. Then we also mentioned that 6 was equal to 11. So if I cut out the two 6's in the middle, I can smush the two ends together to say that 3 is equal to 11 with the transitive property. On this one, it tells us that A is parallel with B. Ooh, excuse me. And if we look at it, both 105 and X are interior angles, and they're on the same side of this transversal right here. So whenever you're on same side inside, you are a pair of consecutive angles. And consecutive angles are supplementary, which means they equal 180, or their sum will equal 180. In other words, x plus 105 is equal to 180. So if I subtract 105 from both sides, I would get x equal to 75 degrees. Alrighty, this, we're going to find the distance that is 4/5 of the way from point A to point B. I'm going to change that up to say find the coordinate or the points that is 4/5 of the way from A to B. In order to do that, you must first deal with your x's only. And the first thing you're going to do is find the distance between your x's using the distance formula, which is the absolute value of x minus x. So in our case, that's the absolute value of -5 minus -5, which would end up being 10. So that's the distance between the two x's. Then you have to take the fraction in the problem, which is 4/5, and you're going to multiply that fraction by the distance for x, which is 10. When you multiply, you're going to get 8. This is your fractional distance. This is the distance from the starting point you're going to have to move. Our starting point is A. So A's x's are originally located at -5. Since we're going to have to move right to get to B, which is at +5, you're going to add 8. If we had to go left, we would subtract 8. So we add 8, which is your fractional distance, to your original starting value, -5, and you would get 3. So this would be the new x. Now we would have to do those same series of steps for our y value. All right, so again, you're going to have to find the distances between your y's. So it's the absolute value of y minus y. Which would be the absolute value of 3 minus -2. Which would equal 5. Then again, you find the fractional distance by multiplying 4/5 by the distance, so that's 5 this time, and you're going to get 4. So now you look at the starting y value, which is -2, and since you have to move up to go from -2 to 3, you're going to add the fractional distance. So I'm going to add 4 to -2, and you would have 2 as your new y. So the coordinate that is 4/5 of the way between A and B would be 3, 2. This problem would like for us to write the equation of a line that is perpendicular to the given line. In order to be perpendicular, your slopes will have to be opposite reciprocals, which means change sign and flip. Okay, well, let's look at the picture and determine the original slope of the line. Here's my y-intercept, and to get to this next point down here, you have to go 2 down and 1 right. So that means the slope is -2/1. So if I needed the slope of a perpendicular line, my perpendicular slope, and this little upside down T stands for perpendicular, would have to be a positive number, and it would be a +1/2, because you have to change the sign from negative to positive, and then you have to flip, bring the 1 on top, the 2 on the bottom. So just knowing that information, I could eliminate choice A and choice C. Now, to figure out if it's going to be B or D, you could substitute the given x and y values into each equation to see which equation balances out. So this would be x, and this would be y. So I substitute y with -2, and then I take 1/2 times x, which is -6, and then subtract 2. So that would be -2 equals 1/2 times -6 is going to give you -3 minus 2. So that would be -2 equals -5, which is false. So B doesn't work either. So my final answer would be D. But again, for proof, you would have to take the x and y values and substitute them in. So y again is -2 equals 1/2 times -6, then plus 1. So that would be -2 equals -3 plus 1, which would be -2 equals -2. And yes, that does check out. This one would like for us to write the equation of a line that is parallel. Slopes, lines that are parallel have the same slope. So the original line has a slope of 4. That means the parallel slope will also need to be 4. And those two little one-looking things down below my M stands for parallel. So knowing that, I can eliminate choice B and choice D. And now, again, you would have to substitute the given x and y value into the equation to make sure it balances out. So this is my equation x, and this is my y. So 10 will equal 4 times -5 minus 10. That would be 10 equals -20 minus 10. So that would be 10 equal -30, which is false. So it's not A, and that leaves us with only C. But again, your proof would be 10 equal 4 times -5 plus 30. That would be 10 equals -20 plus 30, which would be 10 equal 10, which checks out. The key is that perpendicular lines have slopes that are opposite reciprocals. Parallel lines have slopes that are the same. A piece of Miss Alford's dream picket fence is shown below. A diagonal brace is used as support. Find the measure of y. Well, when I look at the two highlighted angles, 60 and y are both between two lines, so they're interior angles. And they are both on the same side of the diagonal, which would serve as the transversal. So same side inside would be, again, consecutive. And we already talked about consecutive is supplementary, which means they add to 180. So that means y plus 60 equals 180. So if I subtract 60 on both sides, y would equal 120 degrees. Graph the image of a glide reflection following the motion rule x minus 8, comma negative y using triangle ABC. Well, according to the motion rule, it wants us to take all our x's and subtract 8. By doing so, the triangle would move left 8 units. And then it wants us to take all of our y values and multiply them by -1. In other words, make every y the opposite y. So if it was originally positive, it'll become negative. If it's originally negative, it'll become positive. So let's list all the original coordinates. A is located at 3, 5. B is located at 5, 7. And C is located at 5, 1. So following the motion rule, I need to take all my x's and subtract 8. So A prime will have an x value of -5. B prime would have an x value of -3. C prime will also have an x value of -3. Then, according to the motion rule, they want us to change all of our y's to their opposites. So 5 will become -5. 7 would become -7. And 1 would become -1. And then we could graph the new triangle. So -5, -5 would be here. A prime. -3, -7 would be here. B prime. And then -3, 1 would be up here. That's C prime. So connect the triangle. Sorry, it's not straight, but you still see the point. So based off of this, what transformations occurred? Well, we already said it translated or slid left 8 units. Then it reflected across the x-axis. Because if you notice, originally B was on top and then C was on the bottom, but on my bottom picture, C is now on top. So there was a flip that took place in this transformation. All right, on this one, they would like for us to solve for x. So if I look at the placement of the given angles, 5x minus 6 is in this corner, 4x plus 10 is in this corner. Since both of them are on the left of the transversal, which is this little diagonal that connects both angles, and they're both beneath the lines that are supposedly or presumed to be parallel, then they are corresponding angles because they're in the same side, same position. And corresponding angles are congruent, meaning they equal. So we put them equal to each other. 5x minus 6 equals 4x plus 10. And then you can solve for x. first subtract 4x, so you would have x minus 6 equals 10. Then add 6, so x equals 16. Alrighty. This one wants you to find the pattern in the picture and then use that pattern to figure out how many will occur in stage 10. Sometimes this works best if you make a T-chart. So you could have the stage in one column and the number of tiles in another column. So what you'll notice is that stage 1, there was 7 tiles. Stage 2 has 12 tiles. Stage 3 has 17 tiles. Stage 4 has 22 tiles. So the pattern you should realize is that each stage increases by 5 more tiles. Or the rule is take 5 times the stage number and then plus 2. So for example, 5 times stage 2 plus 2 is equal to 12. So that verifies. So if I'm using the rule for stage 10, that would be 5 times stage 10 plus 2, which would be 50 plus 2, or 52. How many lines of symmetry does each picture or figure have? Well, this first one, you have a line of symmetry that cuts it horizontally. So that's 1. And another one that cuts it vertically down the middle. So that's 2. So that one only has 2. The one on the bottom, you can only cut it straight across horizontally. Imagine that line is directly in the middle, and that's the only cut that could be made, or fold. So that's only 1. On this one, they want to know if it's possible to find the rotational symmetry. A figure will have rotational symmetry if you're able to rotate it 360 degrees and for it to look like it started. So if I take this picture, this is the original position, and start rotating it 360 degrees, this isn't the first time where it looks like it started. So that's 1 rotation. And then if I take it back, complete the circle, this is where I originally started. So that's 2. So that means the order would be 2. It was 2 times that I was able to rotate it for it to look exactly like it began. And now we need to find the magnitude. The magnitude can be found by taking 360 degrees and dividing by the order, which in this case is 2. So that means the magnitude for this one is 180 degrees. And if you look at the bottom picture, it's going to be the same thing as this picture. So I will pause right here and finish up the review in just a second.